Hello, everyone. So nice to be here. And today I'll be talking about Flutter app to app and the good, the bad, and the ugly parts of it. And few words about me first. So my name is Marcin Chudy. I'm a senior Flutter developer at LeanCode, Flutter software studio based in Warsaw, Poland. And for almost 2 years now, I have been playing a role of Flutter tech lead at one of the major Polish banks. And cooperation with this bank actually started as a proof of concept project using Flutter app to app technology. So that was like the main inspiration to give this talk. And I started mobile dev with React Native actually. Been working with it for a few years, and then I switched to Flutter in 2020 and stayed with Flutter ever since. So as developers, we all love new greenfield projects. We like to start everything from scratch. We like new projects typically because we don't have to deal with all that legacy code that was developed before we came to this project. But many companies would like to invest in Flutter in a cross-platform technology, but they have already existing iOS and Android apps. And just doing a new project in Flutter is often not really an option. But there is a way to go around it and still use Flutter. So there is this feature called Flutter app to app. I don't know how many of you have used app to app, either in production or, yeah, some of you. So for those of you who haven't heard about it before, it's basically a way to either render part of the UI using Flutter inside a native iOS or Android app, or just run some shared dart logic. You don't really have to render any UI. You can only run some shared dart logic. That's also possible. It's been in Flutter since Flutter 1.12, which was released December 2019. So that wasn't there from the very start. It was added later as like an additional feature. And so that's basically what app to app is. And why would you actually want to use it? So like the main reason is that you would like to use Flutter for your app, but you cannot afford a full rewrite. So you cannot just stop working on the existing app or start a new project parallelly, because that would be too much of a cost. But what you can do is perform like a long-term migration. So you start with some small piece of Flutter inside your native apps. Then this Flutter part can grow bigger over time. Either you start writing new features exclusively in Flutter, or start rewriting old features to Flutter. And in the end, you can end up with a full Flutter app. And there is also a talk later today at 3:15 p.m. by Kevin and Lucas that shows actually a success story of such a migration. But our project was a proof of concept, and it was for a different reason. So the stakeholders weren't really convinced that Flutter is capable for a new big banking project. So they figure out app to app is a way to test this technology. And Flutter app gives you a very nice way of showing to stakeholders that Flutter experience is comparable to native experience. So what you can actually do with Flutter app to app, you can rewrite some screen to Flutter and give someone two phones, one with a fully native app and the other with native app with some screen using Flutter. And they probably won't be able to tell the difference if you've done it in a pixel perfect way. And you can go even further with that idea. So you can push it to production. You can run some A/B testing, some user testing. So that's like a very strong proof to stakeholders that Flutter is a good technology for a new project. Some maybe more contrived example, but it can also happen, is that you have some kind of reusable feature, something that you want to use across different apps. And this can be both Flutter apps and some native apps. And here there's cross-platform possibilities of Flutter, and the reusability of the code can really shine. So that's also an option when you can use Flutter Add to App, because you can also support native applications. And in the long term, it can give you a nice cost effectiveness with time. So now you decided that for some of those reasons, you want to use Add to App in your project. So how do you actually go about it? So first, you go to the documentation. There is a section called Add to an Existing App. And I have to say that docs have improved since we used them. They now also mention some more modern stuff like Swift UI. But something that you need to remember is that Add to App is not the default way of building Flutter apps. So if you stumble upon some problem during development, you are much less likely to find some good resources on Stack Overflow and stuff like that. And in fact, if your app is huge, if the app that you're trying to integrate is very big, long maintained, then probably it won't be that simple as in the docs. And on the other hand, if your app is small, then rewrite is probably a better option anyway. So you need to remember that there is this overhead. So now let's get back to this proof of concept of ours. So this was basically for one of the biggest Polish banks. The app that we were dealing with was quite big, so it had half a million lines of code for iOS, 800,000 lines of code for Android, and we were asked to rewrite one complex business process. And we wanted to prove that Flutter is capable for a new project. So this was never a way to rewrite the whole app. The whole app stayed native, at least for the time being. Who knows what's going to happen in the future. But for now, it's a fully native app. But we started a new project from scratch in Flutter. And spoiler alert, the whole proof of concept was a success. So we now publish this fully Flutter app to production. So now let's take a look at how this Flutter Add to App module looks like and what we actually have to think about before going with this technology. So one of the most important things that can have a lot of impact on how you architecture your Flutter Add to App module is navigation. So let's look at this example. So basically we have a couple of native screens. You can navigate through them. And from one of those native screens, you can open a Flutter screen. And maybe from those Flutter screen, you can go to other Flutter screens. So basically, you have like a Flutter module that is a leaf in this whole navigation graph. So once you go to Flutter, you kind of don't go further into some new native flow. So you go from native to Flutter, then you're in Flutter. You can, of course, go back with back buttons or navigation gestures, but generally, the Flutter module is self-contained. And now let's take a look at some different examples. So now we have a native screen, then we go to a Flutter screen, and then we can go either to another Flutter screen or a native screen. And here, from this bottom native screen, we can go to another Flutter screen. So now we see that we're kind of mixing native and Flutter views in the whole navigation path. And that's the moment that we need to talk a bit about Flutter engines. So you don't really need to deal with Flutter engines when you're doing standalone Flutter apps. But with Add to App, it's a very important concept that you will need to take care of a lot. So Flutter Engine is basically a single execution environment for Flutter. And to render any Flutter UI or run any Dart code, you need to start an engine in your native code, iOS or Android. And if we look at this more complex path of navigation, so we can see that we basically have like two separate paths that are separated by native screens. And to go to this first Flutter screen in path A, we need to start an engine because we want to render a new Flutter view. So we need an engine. But then when we go to this native screen at the bottom and we want to start a new Flutter screen, we actually cannot reuse this old engine because this screen is still below in the navigation stack and it needs to maintain its state. So when you go back, you actually have the screen as you left it. And that's not really possible with one single Flutter engine. So in fact, in this case, you need two Flutter engines. And in more complex scenarios, you will need even more Flutter engines. So there are basically two principles with Flutter engines. So one is that initializing Flutter engine takes a lot of time. I mean, a lot. It's like a significant amount of time that you definitely don't want the user to wait before they see the screen. So I'll show you some numbers later on, how the performance like. But generally, you want to pre-warm those engines before you show a Flutter screen. So when to do that, it really depends on your application. So you can do this right after the start. You can do this after login, after entering some screen. You need to develop some heuristics for that. And when you're using multiple Flutter engines, there is a very nice thing that was added in Flutter not that long ago, actually. I think it was 1.5 years or something like that. That's called Flutter Engine Group. That enables you to share resources between multiple Flutter engines. So starting a new Flutter engine will be faster and will use less memory. So that's something that you definitely want to use. And also an interesting case from our project, also related to navigation, was that we had this, the native app used this kind of animation on the top bar. The standard iOS animation. And we had a problem because we had a native screen and then a couple of Flutter screens. And you cannot really, it's very hard to synchronize those animations between native and Flutter screen. So when you have native screen and then Flutter screen, then you could just use the native top bar and just render the Flutter part that's underneath the top bar. And then it's not a problem. But when you have multiple Flutter screens, then Flutter screens will use its own animation between those two screens. And then it gets really messy, basically. And actually, we didn't figure out a full-on solution for that. And in the end, we just rewrote more screens to Flutter because we decided it's just easier to increase like the scope of this module rather than to try to work around this issue. But that's something that's hard to predict, actually, when you start a new project. And now let's talk a bit about the UI. So we all love UI in Flutter because it's a very nice experience to write UI development code in Flutter. And with Add to App, it's basically the same. So once you start working with widgets, it's really the same declarative manner of writing UI code. So nothing's really different from the developer perspective. But there are some other things that you need to think about. So typically, when you have a big native app, the iOS app will have some set of reusable UI components. The Android app will have the same set of reusable UI components, from buttons, checkboxes to some more complex components. And basically, when you want to have like the same consistent experience for users in the Flutter App to App module, you will end up having to rewrite those. So now you have to maintain 3 implementations of those components. So when the designers want to change something, you need to change it now in 3 places. And it's even worse when the UI on iOS and Android is different, which is something that you should actually avoid if you use Flutter, because Flutter is meant to render the same thing. But there might be some differences that you don't want to you don't want to standardize at this point. Maybe some later. Okay, so that's for generic UI components. Now, what about assets? And there's basically, because you also your app is also using some icons, images, maybe some animations in JSON. So basically, can we reuse those native assets so we don't put them in the binary twice? And there is a good news and bad news about this. So the good news is that it's possible on iOS. There is a package called iOS Platform Images. And the bad news is that it's not yet possible on Android. There is an open issue. It's technically possible, but there is like no out-of-the-box solution for now. And also an interesting idea is that you don't have to rewrite everything. So in fact, something that's also possible is that you can reuse some native subviews inside a Flutter view. So that requires some boilerplate with defining platform views and stuff. But in case of some more complex UI components, that's also an option. And in fact, doing it the other way is also possible. So you can have a native screen with some Flutter subviews, but those subviews now will have to use separate Flutter engines. So, but that's also something that you might want to think about. You might have a good use case for that. And now let's talk about networking, because there's a high chance that the Flutter module that you're going to write is not going to be a dump module just to render some UI, but it's also going to fetch some data from the backend or send some requests. And there are basically two ways to do it. And the first way is that when you have the existing native implementation, then why not use it? So we have some native API client built on top of some HTTP client, or maybe some other protocol, and you basically can bridge every request from the Flutter module to the native part using method channels. And the advantage of that is that you don't have to rewrite all those endpoints and models, but also maybe you can generate them, so then this argument doesn't really hold. The authentication logic is handled inside the native app and basically transparent to Flutter, so you don't have to bother with refreshing tokens, setting some common headers, maybe some cookies, stuff like that. Of course, there will be some performance overhead with that, because you need to call the native code, and you still need to implement and maintain this bridge, which can also be quite large when the amount of Flutter code you're writing is starting to grow. And the other idea is just to use Dart HTTP client and build on top of it a Dart implementation. But you will still have some places where you need to synchronize with the native API client. Basically, it's, as I said, refreshing tokens, for example. So the native code can use some request queue, stuff like that. So now we no longer have this extra overhead for further native communication. Flutter devs have full control over the API layer. So we're no longer in this producer-consumer relationship. We'll now have to rewrite all those endpoints and models, but again, maybe we can code gen them. And this whole part of synchronizing state can actually get very tricky in case of bigger apps, which might have some custom implementation and stuff like that. Okay, so now let's talk a bit about is the whole developer developer experience impacted by writing a app. And few conclusions from what we did in our project is that the whole development setup might not be straightforward in a corporate setting. So being this a bank, this is not strictly related to add-to-app, but it's relating to using new technology in a big corporate. They used a lot of proxies, VPNs, artifact management solutions. So actually, before we could start writing any Dart code, it was like a few weeks of unblocking some network issues, setting up artifact management to support pub. So that's something also that kind of gives a huge overhead on such a project. So when you're doing the estimation, it's worth including such things. And the working on the UI, as I said, it's really great. Something that's also interesting, you can run your Flutter module as a standalone Flutter app. So you don't actually have to run the native app to render those Flutter screens you're developing. You can also do this in isolation. Of course, if you're using some native stuff, some method channels, you will have to mock them. But for UI development, this can be very nice. We had to debug natives up a lot, so knowing Android Studio and Xcode really is necessary for that. And with multiple Flutter engines, we actually had a lot of problems with debugging. So the debugger wouldn't always attach. With one engine, it was fine, but when we moved to multiple engines, then it started to get a very shaky experience. Okay, so another thing. So how do we build this actually? So we have a pipeline for building native apps. How do we add Flutter? So again, there are two ways basically. One is to treat Flutter as an artifact. So here we can use Flutter build AAR command, which builds a Maven repository with AAR. We can then link it to the native project. On iOS, we can use Flutter build iOS framework, which actually builds a bunch of Xcode frameworks, one for Flutter, one for your app code, one for each plugin that uses native code, and also some Flutter plugin registrant, which registers all those plugins. And you can add those as embedded frameworks in Xcode. So of course, the main advantage is that native devs don't have to install Flutter on their machines. You can just provide a compiled binary. You don't need to modify the whole CI. At the beginning of the project, we just build binaries in the Git repository, which is of course not a long-term solution, but just to start working with this, it's really fine. And a more streamlined solution is to treat Flutter as code. So basically use Cocoa pods to link to the Flutter code, use Gradle to link Flutter code to Android. You can include Flutter module as a Git submodule, for example. And this is a more streamlined solution, good for the long term, but devs will need to install Flutter locally to be able to do that. And you also need to use Cocoa pods, because I think that's the only package management solution for iOS that's directly supported by Flutter. So that can also be an issue in some projects that don't use Cocoa pods. And now a few words about native code, because the general conclusion is that you will native knowledge to do add-to-app. Flutter native communication is really unavoidable. You will have to write some method channels, do some communication. And I highly recommend you the Pigeon package if you need to do this. So this is basically like a contract generator where you write just some schema in Dart, and this will generate plugins for, some clients for iOS, Android, and Dart. So you will just have to call methods, and you can get some models that you define in the schema file. And that saves up a lot of time. You can also use all packages that are available on pub if you're using app2app. That also includes packages that use native code. So you can, for example, include a camera package in your Flutter app2app module. The fact that you're integrating with the native app doesn't mean that you cannot use any native code written by Flutter developers. There are some caveats, though, to that. So the main one is that if you have a package that contains native code, which we call plugin in the Flutter world typically, you can, and this plugin uses some native library, and your app also uses this library. They need to have the same version, because in the end, the Gradle and iOS will have to use a single version of the library. And that can be a problem if there is a version mismatch there. So you will either have to upgrade the plugin or your native app. So plugin might be easier, but it's some extra work to do. And something that's interesting about our project, which is, I think, is not that typical for app-to-app scenarios, is that the feature that we re-implemented using Flutter was using some background processing. So a simplified diagram of our architecture looks like this. So we had a native screen. From the native screen, we could open like the main Flutter module with a couple of screens, and some action performed on one of those screens needed to start like a background processing logic, which in case of Android was run inside a foreground service. iOS used background tasks, which is a much simpler implementation. But basically, we needed to start a Dart background isolate, which would run in background, and then it could start another Flutter screen. So we basically had three engines here. Those isolates, they can communicate with each other using messages. And we could reuse the native code to do that. So because we had the native implementation of those services, but we wanted to prove that we can actually re-implement the whole logic in Dart. So the whole business logic, which was like a huge state machine, was actually re-implemented in Dart. So we ended up with pure Dart code for business logic, and only some infrastructure code that was Kotlin and Swift. Few words about app size, because adding Flutter will have an impact on your final binary. In our case, it was 27 megabytes for iOS. It was 48 megabytes for APK, including our architectures. And also an interesting story was that the native app was still being uploaded to the Play Store in APK format, which is now not allowed for new apps. But when you have an old app, it was still possible. Now we have to use AAB, Android App Bundle. So actually, when we show them the numbers, also how big of an impact it would be on the existing app, even without Flutter just moving to AAB, the whole company started transition to AAB. And with AAB, the increase was 15 megabytes, so that wasn't that bad. What about performance? So those are some numbers from the official Flutter documentation. The numbers will vary depending on the device you're using. So they're pretty rough, but they're the order of magnitude that you might expect. So on iOS, engine pre-warm, as I said, you should do it in the background. Takes around 860 milliseconds, and rendering the first frame 320, and the further frames will be very fast, but rendering just the first frame takes some more time right after starting the engine. And on Android, it's 1.5 seconds for engine pre-warm and 200 milliseconds for the first frame. And memory consumption, engine pre-warm on iOS allocates 22 megabytes of memory. first frame 16 megabytes, and on Android 42 megabytes for the Android pre-warm, and 12 megabytes for the first frame. You might be doing UI testing in your app. So the good news is that you can still run all your existing native tests after you add Flutter, because that doesn't really have any impact. Of course, if you rewrite, if you have tests that touch the screens that you rewrote to Flutter, then you will have to use some Flutter testing tool, ideally. One of those tools is Patrol, developed by Linkcode. If you want to learn some more things about it, we have a booth here downstairs, booth number 7. What's nice about Patrol is that it has the full native automation, and Patrol tests actually run as native tests. So all the tooling that you use for your UI tests for the native part will just, Patrol will just add new tests to that native tooling. So that won't break anything. And we mostly focused on some technical stuff here, but there are also some other issues. So the technical stuff is not the only thing that we have to deal with when we're building products, especially big products. So I think the thing that you realize when you're faced with such tasks as rewriting something is that the code that you're going to rewrite will have a lot of technical debt. So you will have to deal with legacy code. There might be no documentation for how those features work. It was our case, so there was no official documentation or analysis how any of this worked. And we needed to figure out it from the native code. And we also had no designs in modern designs tools like Figma, for example. So you basically may have to measure pixels yourself from the native screens to re-implement them in a picture-perfect way. And native source is your ultimate source of truth. So if you want to rewrite your app, you want to make sure that it works the same way when wrote in Flutter. You will have to read a lot of native code, and it may be code of bad quality, but some legacy code in Java and Objective-C. So that's something really that you have to remember. And you will need expertise in both Flutter and native. So it's best to have some senior developer that's experienced in both Flutter and native technologies, because you might be a great Flutter dev, great with Dart, but you really will need to integrate with a lot of native stuff here. And something that's also you will have to deal with on a more soft skill level is that not everyone might be fond of Flutter. So you'll be dealing with teams of native developers that really love their framework. They may be reluctant to switch to Flutter. They might not see it as an opportunity, but as an attack to their technology, to their jobs. So that's something that you really need to handle carefully. And also with the rise of Swift UI, Jetpack Compose, this kind of declarative UI advantage, that was always a huge selling argument for Flutter, doesn't really hold anymore that much. So it will be harder to convince them to Flutter in that part. And some final takeaways from all of this. So first of all, every project is different. So I think I've said it depends many times during this talk as a good consultant, but it really is true. So every project is different when you're dealing with big native apps, and you won't be able to predict all obstacles that you will face along your path to the Flutter world. And my general advice would be to try to isolate the Flutter module as much as possible and just let Flutter shine with what it does best. So that's basically the UI. And Add-to-App brings some issues that will not appear in a standalone Flutter app. You should not only focus on the technical stuff, but also on some other factors, like organization structure, technical debt, lack of documentation. And it's always good to consult someone experienced who used Add-to-App in a big project, because they can give you an insight of what you might expect in some more complex scenarios. And a little advertisement. We have this ebook, Flutter for Enterprise. It also includes my article about Add-to-App, along with some other great articles. So feel free to check this out. As I said, there is another talk today about Add-to-App, which I highly recommend. It's about migration path for fully rewriting an app to Flutter. And thank you a lot for listening. I don't know, do we have time for some questions?